Hi, welcome to the first video on the difference quotient. Now this thing's going to look a little abstract. First off, you're going to want to box it. It's right there. That's the difference quotient. What this thing does is it helps us to determine a slope at any point in a function. Super easy to do with a linear. You just end up getting a number. But when you have other things like quadratics, rationals, radicals, those things are curving all over the place, it's really hard to kind of tell different slopes at different points, right? None of those have a constant slope, otherwise they'd be linear. But if those, like for example, let's take a look at a cubic here, some random cubic in space. Over here, it's got a really dramatic slope. Here it's got a really shallow slope, and here it's got a really dramatic slope. So we need something that's going to help us determine a slope at any point, any 2 points, okay? All right, so we're going to find a function that we're going to find a function that helps us determine that slope. So this difference quotient here, we're going to keep h as it is. Okay, h is just another variable. We're going to kind of build on this function arithmetic idea. Okay, so the first thing we're going to need is f of h. So let's go ahead and do f of x plus h. Now we've seen something like this. We did x plus 2, right? We've done, we did it in the last video. We did this guy right here. So you can plug in anything you want to the input. All we're going to do is add an h to the input. And then we're going to simplify it as much as we can. So x plus h squared minus x plus h minus 2. Okay, that binomial squared, I do want to simplify a little bit. X squared plus 2xh plus h squared would be what rolls out of that guy. And then I'll distribute that negative. I don't think any of these terms match, and so that is what f of x plus h will be. Okay, so it's very long, but that is our x plus h function. Now we're going to take that. We're going to do f of x plus h minus f of x over a constant h. And so we're going to copy paste this really long function. And then we're going to subtract our original function. And we're going to put it over h. Okay, cool. Let's do the over h part later. We'll just do this part now. So let's just do this top part. If you already wrote it down, it's fine. So if we simplify this now, then we're going to have this first guy be the same. Minus x squared plus x minus 2. And so what we get is the x squareds canceling each other out. The x's canceling each other out. And the minus 2 is going to turn into 4. So we get 2xh, we'll put h squared first, minus h minus 4 over h. Now, unfortunately, that last thing doesn't have an h in it. Otherwise, I could factor out an h, but I can't. And so my difference quotient, f of x plus h minus f of x over h, is equal to this function right here. If I did know an h, I could plug it in and I could find that number. All right, let's do another one. So over here. All right, so this is my function here. Let's go find g of x plus h. So 3, this one's not too bad. The only thing that changes is here in the denominator. You can add an h there. And then you've got 3 over 2x plus 2h plus 1. But again, we don't see a lot of like terms. All right, so now we're going to take that new guy and subtract g of x. Subtract the original one. 3 over 2x plus 2h plus 1 minus 3 over 2x plus 1. All right, classic rational. Got to subtract these, so we need like terms. So 3 times 2x plus 1 for the first one, because that's what's missing, right? And then minus, whoops, let's just make that a little smaller. Minus 3 times 2x plus 2h plus 1. And they'll both be over both of them. So I'm just going to go like that and write one of them. 2x plus 1 and 2x plus 2h plus 1. Okay, math time. Zoom out a little bit, make sure I have room. Okay. 6x plus 3 minus 6x plus 6h plus 3. Okay, those are going to cancel. Those are going to cancel. I'm left on top with 6h over those two common denominators, 2x plus 1 and 2x plus 2h plus 1. Okay, last thing I had to do, divide it by h. So g of x plus h minus g of x over h. So take what I got, 6h over 2x plus 2h plus 1 and 2x plus 1. It's now over h over 1. So I can look at this as 6x over that thing divided by that, flip that, so I'm just going to flip it here, times 1 over h. The h's are going to cancel. Final product, 6 over 2x plus 2h plus 1 times 2x plus 1 as my difference quotient. Excuse me. All right, so that one was a lot more work because of those rationals, right? We had to subtract a couple rationals. We had to multiply and divide a couple rationals. Let's look at one more for the difference quotient for this video. All right, h of x, we got to find, got to find h minus or plus h of x. That's going to be really fun, but that's okay. That's just the name of the function. We don't really need to worry about that function name, h. So the square root of x plus h minus 2. I mean, that's just the square root of x plus h minus 2. Cool. All right, so now we're going to take that minus original function, square root of x plus h minus 2 minus the square root of x minus 2, which actually can't do a lot. There's not a lot of things to do there. There's not a lot of same bases. There's not a lot of the same. I mean, algebra says, PEMDAS says that we have to do the subtraction first, so they're pretty much stuck. So now let's take that and divide it by h. And honestly, I don't think a lot's going to happen out of that either. And so we are finished. Now you might be thinking, how do you know if something can be simplified? That's all algebra stuff. So again, if you are having trouble remembering what you can and cannot do with algebra, go seek out your teacher and refresh those skills, okay? All right, that is the difference quotient. It is not an easy concept, as it uses both composite it uses multiple parts of arithmetic function. In the next video, we are going to talk about function composites, as we're going to close out this section, and I will see you there.